So, these are your formulas that you guys have to memorize, okay? So, this is the relationship between all of them, okay? So, we have to calculate pH, okay? Now, this is a different math, I guess, tool that you guys are using. We actually have this on a pH, or on a logarithmic scale. And what a logarithmic scale just simply means is that it's in the powers of tens, okay? So everything kind of raises by a magnitude of like 10 by 10 by 10, depending on what pH level you're at, okay? So, pH is negative log times the concentration of whatever hydronium ion we have at the particular time, okay? Now I'm actually going to use these special things called box brackets, okay? And that's meant to be the concentration of a particular substance, okay? So that's how we can calculate pH, okay? We take the negative log, we input it into our calculator, we close the bracket, but whatever concentration we've been given of hydronium, or maybe we have to figure it out, okay, that's how we actually can calculate out pH level, okay? Now, the flip side of this, just to tell you guys like how to use your calculator and so on, okay, to actually calculate the hydronium ion concentration, this is like a backwards and a forwards kind of formula, okay? You go 10 to the negative pH to recalculate back to your hydronium amount, okay? So, have you guys used any logarithmic scales yet? Okay, so this is going to be new mathy type of stuff for you guys, okay? So we'll practice it lots and lots just so you guys get comfortable with it, okay? So these are your first formulas for your calculating pH level, okay? So, in one direction, if I ask for pH and I give you hydronium ion concentration, you should be able to just plug it into the formula and you'll get your pH. If I give you pH and I want you to recalculate back to hydronium concentration, then you guys can put that back into that formula, but these are the two formulas you guys are memorizing for sure, okay? Alright, so let's do an example. So a substance has a hydronium ion concentration of 4.8 times 10 to the negative 12 moles per liter. Find the pH. Alright, so technically what we've got is box brackets around our hydronium ion. Okay, so in box brackets, okay, we know that we have a concentration of hydronium of being 4.8 times 10 to the negative 12 moles per liter. Does everybody agree with that? Okay? Sound good? Sound good? Okay? So, this is like as easy as it's ever gonna get, okay? We do get more complicated than this, but this should be like your easy peasy kind of steps in here, okay? Now, the other thing too that I'm actually gonna kind of ruin your life with is that pH has different significant digit rules than regular values, okay? So, listen, I know, all the groans. Okay, so how many significant digits is this currently as a decimal or as a scientific notation value? 2, okay? So right now this is 2 significant digits, okay? Now, in pH, okay, anything after the decimal is significant, okay? So what this is going to mean is that when we write out our pH number, the number that's before the decimal is not significant, okay? Because this only travels in powers of tens. That's apparently not significant in the world of scientific significant digits, okay? You're only going to have 2 decimal places for your pH level. So let's input this, okay? So if we go negative log, okay, 4.8, and guys, the other thing too, oh, sorry, you can't even see it. Okay. The other thing too, did you guys know that there's like a sneaky faster way to kind of like figure out your times 10 to the? Okay, So you put in, so everybody should see negative log 4.8. Okay?
Wait, I don't even see
Negative log. Negative log is like at the right beside the 7. Does everybody see it? Okay? Yeah, it's learning how to use your calculator, which is crazy. Okay, so leave the 4.8. Okay? If you press second, and then where the comma is, there's an EE. Does everybody see that? Okay? And you can actually get like a little E. What that actually means in like quicker calculations is times 10 to the. Okay? So you do not have to always do times 10, little hat thingy, and then like whatever numbers, okay? So in this case here, all you have to do is 4.8 E negative 12, close the bracket, and then you press enter. So what value do we get for our pH? Okay, so 11.3187 blah 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 is what we end up getting. Everybody agree?
Yes.
Okay, so this is where the significant digits come into play. pH uses significant decimals, we'll say. Okay? So, because this original value had 2 significant digits, that means that the pH number is just going to have 2 decimal places. So what this pH number for the correct amount of significant digits is going to have is 11 point, and correct rounding as well, 32. And that's all you have to put. There's your 2 significant digits for that value.